Hello everyone, welcome to Grade 12 AP Physics, Mastering Free Body Diagram in Minutes. In this video, I am going to go over the solutions to the quiz in our app. If you don't know what I'm talking about and if you are interested in taking this quiz, please go to our link in the video description to download your app for Android and iPhone. Solution to question 1. So in question 1, a block is suspended from the ceiling with a string, and we must draw the free body diagram that lists out all the forces that are involved. Well, this is a very simple free body diagram because there's essentially only two forces that are involved, namely the tension, which is by the string, and the gravitational force. So if we to draw this, we would draw the block and we would draw the angle, the arrow pointing upwards, and mark it as T, or the tension for the string, and we would mark another arrow pointing downwards and labeled it as FG, or the gravitational force. Question 2 solution. In question 2, this is a very classic inclined plane free body diagram problem. So in this case, we got the block of 10 kilograms situated on a 30-degree inclined plane, and it is not moving. So if we were to draw the free body diagram, it would be of something like as shown in the current view. Now, there are four forces that are involved in this case, and that would be the gravitational force due to gravity, which is Fg, and it's pointing downwards. And then you would have the normal force, which is perpendicular to the surface. Now, with regards to that, because of the gravitational force, there's also a force that's gonna make the block slide downwards because of gravity, and we would mark this as force downhill, or FD, due to simplifications. Now, why would it not be moving? Well, of course that there is another force that's acting against it, which is the frictional force, in which we would label it as FF, which is pointing uphill on the inclined plane. So how do we solve this problem? Well, the easiest thing to go about is the gravitational force, which is mass times the acceleration due to gravity, and 10 kilograms times 9.81 meters per second square would equate to 98.1 newtons. So how do we find the normal force? Well, you can memorize this, but it's also by just a series of trig properties. And so if we have the gravitational force multiplied by the cosine of the angle of the inclined plane, we would get the normal force, of which it is 84.96 newtons. Now, coincidentally, the downhill force would be the sine of that, and which is 49.05 newtons. And because you know that the block is not moving, you know the counter force, or the FF in this case, will also be 49.05 newtons. Question 3 solution. So in this scenario, we have a teeter-totter, and a 50-kilogram child is sitting 5 meters from the central point, or what we call a fulcrum. So if we were to sit a 30-kilogram child on the other side and have it balanced, we need to move it based on how we calculate torque. So how do we calculate torque? Well, we know that we calculate torque by multiplying the force, the gravitational force, by the distance of that object from the fulcrum. So in this case, we know that in a balanced scenario, you know that the torque established by the 50 kilogram needs to be equal to the torque established by the 30 kilogram for it to be fully balanced because of equal torque. So if we put in the equation, we would have 50 kilograms times the acceleration due to gravity, which is 9.85, times 5 meters. And that would equal on the other side of the teeter-totter, which is 30 kilograms times the acceleration of gravity and times the unknown distances from the fulcrum of the teeter-totter. So if we actually multiply this, we would have something where end up with 250 equals to 30x. And if we divided that, we would have x equals to 8 1/3 meters. And thank you for listening to our video. This concludes the lecture. If you are interested in more studying materials, please download our physics app and other AP course study apps. This can be found in the links in our video description through YouTube. Also, if you want to keep up to date with our latest videos for studying purposes, please subscribe to our YouTube channel, and please share our videos via Twitter and Facebook.